Hello, physics students. Today I thought it would be nice if I made a quick little video on how to write the inverse square regression program. Okay, so here's what's been going on. Over the last months, could have been years, you've been gathering data. You've had two objects here that you know they're attracted to each other. It's a magnetic force. I'm not sure what it is, but you recognize that when the distance between them increases, you have noticed that the attractive force between them has been decreasing. Okay, so you've gathered this data, you've worked tirelessly on your experiment and made great observations, and you have this fantastic data. Where do we go from here? Okay, well, from here, we want to be able to create a mathematical model that is going to describe this data. So from here, what you want to do is you want to go to Stat, you want to go to Edit, you want to put your data into your calculator, okay? And then once your data is in your calculator, you can go to Stat Plot, make sure your plot 1 is turned on and that you are graphing L1 and L2, okay? So go to, and then we just do a zoom 9, and then that will fit your data to the screen. Okay, so look at your data. Well, this is exciting. You've been working so long on this data. You're looking at this and you say, oh, well, it looks to be an inverse square relationship between the force and the distance. So you've made that observation. So what equation models this data? Well, in order to do this, you know that the relationship, like we said before, is inverse squared. So the inverse square relationship looks like this from algebra. Okay, y is equal to k over x squared. Okay, so your y data is stored in L2. Your x data is stored into L1 there. Okay, so what is the value of k? Well, if we multiply both sides by x squared, we see that k is equal to y times x squared. Okay, so in the calculator, a good approximation for k would be to take y, that's your L2 data, and multiply by your L1 data squared. Okay, and if we do that, then we'll have a whole bunch of k values, and we'll just get the average. The average of these would be the best approximation for k. Okay, so we're going to do this. We're going to make our calculator do this for us. So the way we do this is we go to Program, we go to New, create a new program. We want an inverse square program, so I'm going to type where's INVSQ for inverse square. Okay, and then I'm going to go to Program. First thing I do is I always clear the home screen. So Program over to IO and down to Clear Home, which is number 8. Okay, now we're going to do L1 squared times L2, don't have to use the times key, times L2. We're going to store that. Now your store key is right here above the on key. Store this into L3. Okay, and then after we do that, we want the average. So all of our k values are now in L3. We want the average of our L3 value to store that into k. So to get the average, we go to Math. We go to, I'm sorry, I did that pretty quick. Second, Stat. Get you into List. Go over to Math and down to Mean. And we want the mean of L3. Okay, and we're going to store that into a variable k. All right, and the last thing we want to do after we've done this work here is we want to output the value of k to the screen. So we want to go to IO, go to Display, and then I'm going to do alpha quote k, alpha k, and then equals. To get the equal sign, we need to go into Test. So second, Math, get that equal sign, close quote, so that's alpha plus sign, and then a comma, and then alpha k. And that is all we need. So when we run this program, we're going to go to Program, Inverse Square, and we get our k value is 100. Okay, so we know now that our k value is 100, so we know that y is equal to 100 over x squared. Okay, and this is the mathematical model. Now, to fit this back to our original data, we had force is our y value, and our x value was distance. Okay, and then how to get the proper units on the 100? Well, we've covered that in a previous video. All right, well, hey, thanks for your time, and we'll see you in the next video.